Dear students, today what you see here is called a meter bridge. A meter bridge is called a meter bridge because it has a wire fixed here on the scale which is 1 meter. This wire is made up of an alloy or material like constant tan. Why? Because it has high resistivity. Yes, this is a wire we have taken. Now, this wire is fixed on a meter scale, that is 100 centimeter, and that is fixed on a wooden board. You see here there are certain plates, they are all copper plates. There are certain terminals. Now you come to this part here. What you see here, this is a battery eliminator which gives you electricity. We can use only an ordinary cell for this experiment. It will work. I have taken the positive terminal of the battery connected to one end of the meter bridge. I call this as A and I call this as B. At A I connected positive. From negative I have taken a key. What is a key? You see, key is a switch actually. You see, there is two terminals are there. Now the circuit is open. When I put this inside, I place it, then it is closed. It is closed. Again I repeat carefully. Two terminals are there. And you see here one in between. When I place the key, when I place the plug-in, then it becomes, the circuit becomes closed. That is what you see here. From the other terminal, I have taken to the other end of the bridge called B. So this is the primary circuit. This is the primary circuit. Now what is the purpose of a meter bridge? It works on the principle of Wheatstone bridge, which you saw in the video, which is P upon Q is equal to R upon S. Using Kirchhoff's law, we derived P upon Q is equal to R upon S. Using that principle, the meter bridge is going to work. Yes, before I say what is P and Q, I will say what is R and S. There are two terminals here. I got a resistance box with me, right? There is a resistance box, two terminals are there. I can put any value in this. 1 ohm, I take it out, 1 ohm. I want to put 2 ohm, I take it out, it becomes 2 ohm. I want to put 3 ohm, 2 plus 1, 3 ohm. Right. Now, let me place it back in its position, right? And again I will explain it to you. How a meter bridge is about. What a meter bridge is about. See carefully. A resistance box is there. Fine. There is 1 ohm, I plug it. That means 1 ohm will come in the circuit. I take out 2 ohm, 2 ohm will come in the circuit. So then 1 ohm should be put back. Fine. So I want 5 ohms, put 2 ohms back and come to 5 ohms. Fine. So I can have any combination of resistance, and this is called a resistance box. Now, I am going to connect this to the two terminals of the meter bridge. Copper plate is there. I am connecting to the two terminals, two ends of the resistance box. Now, let us see, watch carefully. Now I have connected these two. This is R. This resistance box represents R. This is a known resistance. Now I have with me S. This is the resistance whose resistance value I have to calculate, and this is S. You got R and this is S, unknown resistance. I connect this into the two other ends, terminals of the meter bridge. Very carefully let us do this experiment. Fine. So this is the resistance whose resistance value I need to calculate. Fine. So let me connect the two terminals ends of it. Yeah. Now you see carefully, I have arranged it. Yeah. Now we have to calculate the unknown resistance. This is the unknown resistance you have to calculate. Fine. How do you measure? We learned about something called null deflection. Who will give you the null deflection? The galvanometer. This is a galvanometer. It has a center scale and left 30 milliampere, right 30 milliampere. There is no positive, negative, only the reflection will be right or left. Galvanometer measures small current. Now, I take the galvanometer, I connect it to the middle point of the meter bridge. You will be connecting to the middle point of the bridge. Now, the second point is, right, I connect it to your jockey. I connect it to your jockey. What is a jockey? Jockey is a connector. That's all. You see, it is a connector. Now what is happening? It has one terminal here. Through this metal is going and there is a sharp point here, you see, which I am going to move it over the wire. This is a sharp point. I connect the galvanometer to the other end to the jockey. Fine. Now, this is done. What is the next step? We know R and S. And where is P and Q? When I switch on the circuit, right? Let me on the circuit. Now circuit is on. The switch has been put here. Okay. Now the circuit, primary circuit is working. I take the jockey and I check it first. I see, I keep it in the left. Yes, the galvanometer is deflecting towards left direction. I think you can watch now. You see, I am going to keep it in the left and it is going in left. Okay. Now what I am doing it, I am going to keep it in the right and again it is going in left. Again it is going in the left. Yes, circuit is of course correct. Let us switch it off now. Let us pluck out. Actually in the experiment, when you place it in one end, it should deflect in one direction. When you place it in the other end, it should deflect in the other direction. Yes, when that will happen? When P upon Q is equal to R upon S. When this value matches this value, then that will happen. Now again I am tapping it so that the key is perfectly fit. Now what I am going to do? I am going to take the jockey and I take out some, let us say 2 ohm resistor. I take 2 ohm resistor and I put it now, keep it left. Yeah, let me on it again, put the switch back, on it again. Fine. Yes, left and the other side is again left but little less. Let me again now leave this, put 5 ohm resistor. Okay, and tap it little so that connection is proper. Again I place it left and again it is left. We go on adding. Let me take for example 1 ohm resistor. Maybe the resistance is too less. 1 ohm resistor left and it is slightly left. When I match the resistance, let us say 10 ohms I put. Okay. Now let me take it to the left hand side of the wire and I take to the right end of it. Okay. Now I move the jockey over the wire slowly like this, like this, like this. At a particular point, when R and S are matching with each other, when R and S unknown value are matching with each other, the point where I get the null deflection, where there is no deflection, where the deflection is 0, it is neither left nor right. At that point I notate, right? And it comes to me, let me again do the experiment, right? Let me do the experiment, and 42, 43, 43.5. Okay, 43.5. For me, the balance length came to be 43.5. What is the whole length of the wire? 100 centimeter. And this part of the wire is the resistance of this wire is P. And 43.5, beyond that, 100 minus 43.5, that is 56.5, that gives you Q. P upon Q, the resistance of the wire which we have taken constant and wire, when that is giving you the balance length, P upon Q is equal to R upon S. From this, we can calculate P upon Q is equal to R upon S. And you know, resistance is directly proportional to length. R is directly proportional to length when resistivity, the wire you have taken, is same, and also the area of cross section of the wire is same. The area of cross section of the wire is constant, and the resistivity of the wire is constant, and then the resistance is directly proportional to length. So we know that P upon Q is equal to R upon S, which is equal to, where I get the balance point for null deflection, 43.5, right? See, let me on it again, and the balance condition is around 43.5, and that time P upon Q is equal to R upon S is equal to L upon 100 minus L, from which we can calculate the resistance, unknown resistance of the wire. This is a working of a meter bridge, and in the theory part on the board, I will explain to you through a next video how we can do this theoretically. Thank you so much.